Welcome to Pre-Calculus. Today we will investigate expanding binomial powers. We'll take a look at three examples. Our first example is y plus 2 to the power of 3. I can see definitely that this is a binomial because in my parentheses I have two terms connected by addition or subtraction. So that's where the binomial part comes in. And then I see that I also have a power, in this case, power of 3. And so when I say I'm trying to expand a binomial power, really I'm trying to take this y plus 2 and I want to multiply it out. So if I think literally what y plus 2 to the power of 3 represents, it's really y plus 2 times itself 3 times. So I can record it as y plus 2 times y plus 2 times y plus 2. So I want to multiply that. And the way that I would approach it is piece by piece. I would start by taking two of these binomials and finding their product. So with binomials, we really are doing double distribution, the FOIL method. So I'm going to multiply the first terms. Y times y is going to be y squared, plus the outer terms, y times 2 is plus 2y, plus inner terms, 2 times y is also 2y, and then plus the last terms, 2 times 2 is 4. So I see for this kind of intermediate step, what I've got is y squared. I will always be able to combine those middle terms, 2y plus 2y is plus 4y, plus 4. So again, if I think in terms of my original y plus 2 to the power of 3, it's y squared plus 4y plus 4 times the third y plus 2. Once I've got it down to two polynomials, then I can multiply those two together, and that'll complete the process. One way that we can multiply really trinomials or higher is by setting up a grid. So I'm going to take this trinomial y squared plus 4y plus 4, and I'm going to put my binomial terms y plus 2 as a column to the left. And then I just want to multiply each term times what it pairs up with in the column in the row. So for this first product, I've got y to the first times y squared, that's y cubed. And I'll just move to the right. 4y now times y is 4y squared. And lastly, y times 4 is 4y. Now down to that second row, y squared times 2 is 2y squared. 4y times 2 is 8y. And 4 times 2, my constant term there is 8. One advantage of using this arrangement, I have my like terms organized along the diagonals. So I'm going to circle the diagonals. And that'll help me to bring this expression out of the chart here, out of the grid. So I'm going to start with y cubed. Then I'm going to add 2y squared plus 4y squared. That's plus 6y squared. And then 8y plus 4y. So that's going to be plus 12y. And then I just have one constant term plus 8. So it turns out y plus 2 cubed is equivalent to y cubed plus 6y squared plus 12y plus 8. So that was a smaller power, power of 3. Let's take a look at an example for a higher power. Here we have 2n minus 1. That's my binomial to the power of 5. So again, just to think about what that really represents, that's 2n minus 1 times itself 5 times. So we'll record it just so we can see an expansion here about how it looks. 5 times, so there's 4 of them and there's a fifth. So literally that's what we're trying to multiply. 2n minus 1 times itself 5 times. I'll start the same way by multiplying a pair of these binomials first. So again, that's a FOIL method. 2n times 2n is 4n squared. Outer terms 2n times negative 1 minus 2n. And because of this arrangement where it's the same binomial, the middle terms, the inner terms will be identical. So again, minus 2n. And then last term's -1 times -1 plus 1. If I bring this all together, that's really 4n squared minus, if I combine my middle terms, 4n plus 1. Now, I can think at this point that this second set of 2 is also going to be 4n squared minus 4n plus 1, since they're the same exact binomials. And then I'm just going to tack on the fifth binomial, 2n minus 1. So I'm almost ready to set up the chart, but what I need is to multiply these latter 2. I only want to, in the end, multiply 2 polynomials. So I can do distribution here. It's really triple distribution. So we'll just use our arrows to get this multiplied. 4n squared times 2n is going to be 8n cubed. 4n squared times minus 1 is minus 4n squared. So I'm finished with that first term. Now I'll move to the second one. Negative 4n times 2n is minus 8n squared. Negative 4n times -1 is plus 4n. And now I'm ready for my last term. It's a 1, so it's really just 2n minus 1. I'll combine the like terms there. This is going to be 8n cubed. My next 2 terms are like terms, both powers of n squared. So minus 4n squared minus 8n squared is minus 12n squared. Plus 4n plus 2n's plus 6n and minus 1. So now what I'm really multiplying are these 2 polynomials. 4n squared minus 4n plus 1 times 8n cubed minus 12n squared plus 6n minus 1. Let's set that up as a chart like we did previously. So I'll take that first trinomial, 4n squared, we'll give this a row, minus 4n plus 1. And then we'll put the 4-term polynomial, the cubic, 8n cubed minus 12n squared plus 6n minus 1. And again, the chart will help us to organize like terms, and it makes sure we actually do all the products that we need to do. So I'll just create our tic-tac-toe table there. And let's multiply. So I'm going to start in the upper left here. So 8n cubed times 4n squared is going to be 32 n to the power of 5. Move to the right. 8n cubed times negative 4n, that's negative 32 n to the 4th power. 8n cubed times 1 is 8n cubed. Now my second row, negative 12n squared times 4n squared is going to be negative 48 n to the 4th. And I see already my diagonals are, in fact, like terms. So again, the table helps us to organize our data. Negative 12n squared times negative 4n is 48, positive 48n cubed. And then negative 12n squared times 1, negative 12n squared. Row 3, 6n times 4n squared, 24n cubed. And just like with my powers of 4, my powers of 3 are aligned in the diagonal. 6n times negative 4n is negative 24n squared. 6n times 1 is 6n. And my last term is negative 1. So really I'm going to put these 4n squared minus 4n plus 1, just switch the signs. I'll have negative 4n squared. That completes my square diagonal. Positive 4n, that completes my linear diagonal. And negative 1. So I'm ready to bring that out of the table now. So I'm going to just write equals. So it's going to start 32 n to the power of 5. Then I'm just adding up the coefficients in the diagonal. Negative 48 plus negative 32. It's going to be negative 80 n to the power of 4. on my n cubed diagonal, I have 3 terms. So I have to add up 24 plus 48 plus 8. And that's going to give me, again, if I add that all up, 24 plus 8 is 32 plus 48. That's positive 80 n cubed. For my square diagonal, I have negative 4n squared, negative 24, and negative 12. If I add those all together, negative 4 plus negative 24 is negative 28. Negative 28 plus negative 12 is going to give me minus 40 n squared. My linear diagonal just has 2 terms. 4n plus 6n is plus 10n and minus 1. So that completes the product of a higher power, power of 5. Notice we did have some coefficients in this binomial. So that definitely changes the way the coefficients look like in the final product. Here's our final example. Here we want to multiply m to the power of 4 plus 3n cubed to the power of 5. So again, what I want to do first is list it out so that I can pair up factors. M to the 4th plus 3n cubed. And we're going to write that again 5 times to represent the power of 5. Our strategy here is the same as the previous example, but just notice the difference is really in the complexity of the binomial itself. The binomial here has both coefficients and powers within the binomial. So again, just the same as that previous example, I'm going to start with 2 of these. And we'll FOIL it to begin. So m to the 4th times itself is m to the power of 8. Outer term, m to the 4th times 3n cubed is going to be plus 3n m to the power of 7. Inner terms, same thing. 3. Actually, I see that I'm confusing m's for n's. So let me correct that. I had said it correctly at first. So this is actually going to be 3m to the 4th n cubed. Make that correction. And then my last term, 3m n cubed times itself is going to be plus 9n to the power of 6. Again, I want to combine my middle terms in that trinomial, m to the power of 8 plus 6m to the 4th n cubed plus n to the power 9n to the power of 6. So just like we done previously, I can again pair up another set of those exact same binomials. It will have the same product. So that's m to the 8th plus 6m 4th n cubed plus 9n to the 6th. And I'll just import that last m to the 4th plus 3n cubed. My next step, just like we did in a previous example, is to merge by multiplication the last 2 polynomials. So that, again, that's going to be triple distribution. So we'll draw our arrows. M to the 8th times m to the 4th is m to the 12th. M to the 8th times 3n cubed is plus 3m to the 8th n cubed. Now to the middle term, 6m to the 4th n cubed times m to the 4th. That's plus 6m to the 8th n cubed. And the second one for that term is going to be plus 6m to the 4th n cubed times 3n cubed. So that's plus 18 m to the 4th n to the 6th. And our last product is going to be n to the 6th times m to the 4th. So I'm going to wrap this around here. That's going to be plus 9n to the 6th m to the 4th. And lastly, 9n to the 6th times 3n cubed is going to be plus 27n to the power of 9. So let's put our kind of our intermediate terms here. I've got from that first one, we hadn't changed, m to the 8th plus 6m to the 4th n cubed plus 9n to the power of 6. And then for this second polynomial here, I've got m to the power of 12. I see that these next two terms are like terms. They both have m to the 8th n cubed, so it's 3 plus 6, that's plus 9. M to the 8th n cubed. I have a difference between my next two terms. One is m to the 4th n to the 6th, whereas the other is n to the 6th m to the 4th. So we got to put them separately. Plus 18 m to the 4th n to the 6th. And I actually see I've got those inverted, and that's why I'm not seeing them as like terms. They actually are. Let me fix the order here. M to the 4th, n to the 6th. So we'll add those. 18 plus 9, that's going to give us 27. M power of 4, n power of 6. And then lastly, plus 27, n to the power of 9. Once I've got it into two polynomials, again, the way I want to set it up is in the table. So I'm going to, again, I'll put that first trinomial across the upper column. So it's m to the power of 8 plus 6m to the 4th n cubed, and then plus 9n to the power of 6. And again, I'll put the 4 terms in the second polynomial along that column. So this is m 12th, 9 m to the 8th n cubed, plus 27 m to the 4th n to the power of 6. And lastly, 27 n to the power of 9. So there's my setup. I'm going to put the table set up here as well. And there's my tic-tac-toe table. So again, I'm going to multiply now by row and column. So m to the 12th times m to the 8th, I add those powers, m to the power of 20. M to the 12th times 6m to the 4th n cubed is going to be 6m to the power of 16 n cubed, 9m to the 12th n to the power of 6. Now in my second row here, it's going to be 9m, I add my 8s to the power of 16 n cubed. And even in this arrangement, I do have like terms along the diagonal. 9m to the 8th n cubed times 6m to the 4th n cubed is going to be 54 m to the power of 12 n to the power of 6. And my last one in this row is going to be 81 m to the power of 8 n to the power of 9. Now to my third row, 27 m 4th n to the 6th times m to the power of 8 is 27 m to the power of 12 n to the power of 6. And that gives me another diagonal of like terms. 27 m to the 4th n to the 6th times 6 m to the 4th n cubed. Let's check that product, 27 times 6. So that's going to give me 162 m to the power of 8 n to the power of 9. So notice we are adding those powers. When you're multiplying, same base, different power, you add the powers. Also, we need 27 times 9. We'll just multiply that here. That's 243. M to the power of 4, that's the only m term, n to the power of 12. Last row, this is going to be 27 m to the 8th, n to the 9th. And again, that's one more diagonal of like terms. And lastly here, 27 n to the 6th, n to the 9th, I mean, times 6m to the 4th n cubed is going to be 162. M to the 4th, n to the 12th. That's my last row of common terms. And then my last product here is going to be 27n to the 9th times 9n to the 6th. That's 243 n to the power of 9 plus 6, 15. So once I've got that set like that, I just need again to pull the terms out. So this is going to be m to the power of 20 plus, if I add my coefficients 9 and 6, that's 15 m to the 16th n cubed. Okay, my third row is going to be 27 plus 54. We'll move our calculation box here. So it's 27 plus 54 plus 9. That's going to add up to 90. So plus 90 m to the 12th n to the 6th. My next row, I've got to add again 27 plus 162 plus 81. That's going to add up to 270. So plus 270 m to the power of 8 n to the power of 9. And then again, I'm going to move my calculation box. Got one more sum to find, 162 plus 243. And that's going to add up to 405 m to the 4th n to the 12th. And then lastly, my last term there, plus 243 n to the power of 15. And that completes that multiplication. We see our product there. Thanks for joining for these examples about how to expand binomial powers manually. We looked at a few examples here, all of them binomials, some as our first example, just a variable plus a number, all the way up to this last example where I've got powers and coefficients and multiple variables in the binomial. Again, thanks for joining. See you soon.